Welcome to this video. We're going to be talking about how to solve polynomial equations. So I want you to start by thinking about this question. Suppose there are two numbers and the first number squared plus the second number equals 11. Then the first number doubled, so 2 times the first number, minus the second number equals 4. What are these two numbers? Pause the video for a second and see if you can figure this out. Okay, hopefully you had the chance to figure that out. In a second, we're going to go over it and see how we can solve this situation using polynomials. So we're finally ready to start actually solving polynomial equations. We've already manipulated them, adding, subtracting, multiplying, dividing. We understand where they come from, and now we are going to actually solve them. We're only going to deal with real roots, no complex roots, and we're going to stick with graphing as our method of solving. There are other ways, but graphing is a reliable way that we're going to use. So when we say solve a polynomial by graphing, what we're really trying to find is where does the graph of the polynomial cross the x-axis, or for what values of x does f of x equal 0. So here's an example of polynomial. It's really wild above the graph, but notice it crosses right there at -1. So that is your root or your solution, x equals -1. Okay, so let's try an example, and we're going to specifically do the example from the do now. So to remind you, there are two numbers. The first number squared plus the second equals 11, and the first number doubled minus the second equals 4. So we can write this as two equations. X squared plus y equals 11, where x is the first number, y is the second number, and 2x minus y equals 4. So those are our two equations. Let's actually substitute, let's resolve the second equation for y, and then plug that into the first equation. When we do that, we get x squared plus 2x minus 15 equals 0. That is a quadratic we can solve. So we graph it, and on Desmos you can see it crosses at two places, at +3 and -5. So there's two possible values for the first number. The first number could have been 3 or 5, 3 or -5, and by consequence, the second number must have been 2 or -14. So you might have figured it out. 3 and 2 works. 3 squared plus 2 equals 11, and then 2 times 3 minus 2 equals 4. So 3 and 2 work, but actually also -5 and -14 also work. Okay, so on Delta Math, you're going to need to know how to create a table and actually graph some of the values of the polynomial. So I'm going to show you how to use Desmos to quickly give you this table so you don't have to go and crunch all these numbers by hand. So let's see how this is done on the next slide. One really nice thing about Desmos is that you can use it to evaluate a function for you much quicker than you could by hand. So given your function, whatever it is, you need to write it in this form. F of x equals, and then whatever your function is. Go to the second spot and place a table there. You're going to notice you have x sub 1 and y sub 1. You're going to want to change the second one to actually be f of x sub 1. Now, whatever I put in for x sub 1, it's going to evaluate that into my function and give me the output value. So I'm going to put all numbers from -9 to +9. So -9, -8, -7, -6, -5. And notice it starts to automatically populate, so I just keep pressing enter until all the way I get to +9. And I've got all these values. Now this is important because these values will help you graph the function when you're doing it, the problems on Delta Math. So this is a very useful tool for evaluating functions quickly using Desmos. Okay, so once you solve the equation, or once you solve the polynomial, you're going to need to rewrite it in factored form. So look at this example. We've already solved this polynomial. We've got our three solutions here. -8, 2, and 5. But when we rewrite it, we write it like the opposite sign. So x plus 8 times x minus 2 instead of +2, and x minus 5. So this and these two polynomials are equivalent, but the second one clearly shows us the solution, so we call that factored form. You're going to need to write factored form when you solve the questions in Delta Math. Speaking of Delta Math, you've now learned everything you need to know, so go ahead and work on those practice problems and let me know if you have any questions.